Electrolysis of dilute H2SO using platinum electrolysis of dilute H2SO platinum electrolysis. Platinum electrodes are inert electrodes. Let's see. Make a rough diagram. You will be getting ideas easy. This is platinum. H2SO, dilute H2SO means H plus ions, sulfate ions, and water. H plus ions, H2 mixed with H plus ion again, right? And sulfate ions and water. Cathode. At cathode, what all things will go? H plus can go and water can go. H plus cathode is a reduction. One electron gives H and two electrons. Then water can, this is what? This is 0.004 and then reduction potential. And H2, H2O production. H2O production is base and hydrogen. Base and hydrogen. It's minus 0.83 volt. Minus 0.83 volt. At cathode, higher inert value is preferred. So what is preferred? This one is preferred. So I am cutting this. And at anode, at anode, again competition between sulfate and H2O. Go to the trend. And what is the trend? SO2 minus, NO3 minus, H2O. You can make out that H2O will go first, lower inert value, lower side. At anode, lower inert value is preferred. So not sulfate, H2. So H2O will undergo oxidation. Anode में oxidation phase. Oxidation means removal of electron, acid will be produced and oxygen will be produced. So in the trend, you don't have to write this inert value at all. They will ask what are the products. You have to write just the products. Selection and all that all internal matters. You have to give the product. If you first you have to give the products. After that only you give the explanation. Right? They will not. This is a one mark. They will not go through these sentences or these equations and all. And if you are writing the products in the end, then make it in a big box so that examiner is able to see that quickly. So what all things are there? H2. At cathode, H2 and at anode, O2. You know that acidified water, when electrolyzed, we get hydrogen and oxygen. This is the method to get hydrogen and oxygen from water by electrolysis. Okay, next is with attackable electrons. In the case of attackable electrons, anode that will undergo oxidation and it will get dissolved. So for example, with silver electron. With the silver electron, silver is attackable. So it is silver Ag. This is not platinum or gold. Silver is attackable electron. Its solution, that is silver nitrate solution, AgNO3 solution. That means AgNO3 and water. What are they? At cathode. At cathode, reduction. That means Ag plus can undergo reduction to form metal, coinage, and water can undergo reduction to form base and hydrogen. That is minus 0.8. Of course, at cathode, higher inert value is preferred. So we'll be selecting this thing and we are crossing this, right? And at anode, since it is attackable, the electrode will get dissolved. Means Ag will change to Ag plus. Accordingly, equal number of Ag plus will get deposited on this. Ag plus will be undergoing reduction in the solution and deposited on Ag plus. So, anode will write anode will dissolve, anode will dissolve, anode will dissolve. Product means there Ag changes to Ag plus 1 is. So in this way, if it is attackable at anode, you will write anode will dissolve and give this dissolving equation. Ag is getting dissolved into Ag plus. Metal is getting dissolved. So that's about the product of electrolysis. We are moving to the next chapter, that is chemical kinetics. Kinetics means speed, velocity. At macroscopic level, we talk about amount of the reactants, the amount of the product. At microscopic level or at molecular level, we talk about the reaction mechanism. In this chapter, we will be dealing with the amount, quantity of the reactants, quantity of the product. That means at macroscopic level, big level. At smaller level, we go to the atoms, molecules, and at a bigger level, we will be talking about this much gram reactant, that much gram product is known as amount of fertilizer made. And we'll be talking in terms of kilos and tons and all these fertilizers and chemicals. What is meant by the speed of the reaction? I told you, it is the speed means when a reaction proceeds, the reactants are getting reacted means the amount of the reactants that is getting decreased and decreased and decreased. In the beginning, there is no product, that is zero product. As the time passes, the amount of product is increasing and increasing. So what is meant by the speed of the reaction? Either you can talk in terms of the decreasing way of reactants, or you can talk in terms of increasing way of the products. You can catch hold of any one reactant or any one product. So speed of the reaction means that is the change in concentration of the reactant or the product in unit time. The change in concentration of reactants, any one of the reactants or any one of the products in unit time. Suppose we are taking generally RVs. This is reactant, this is product. Any one of the reactant, any one of the product. Let initially this R1 or at a time R1, that time P1. After some time R2 is the amount of reactant which is lesser than R1. Amount of R2 is lesser than R1. At that time P2, amount of P2 is greater than P1. This happened within a time delta T is the change in temperature. What is the change in concentration? That is R2 minus R1. I told you R2 is a lesser quantity and this is a greater quantity. So of course less minus more will be having a negative value, but we know that speed cannot be a negative value. So to make it speed positive, simply we are putting one minus, that is R2 concentration in terms of polarity, that is put in square brackets, minus R1 upon delta T, that is unit time, in unit time. And this quantity we are writing it as delta R upon delta T. We are putting simply minus to make it as a positive quantity. What about in the case of products? That is delta P, that is positive delta P. Anyway, P2 is greater than P1, so P2 minus P1 is always a positive quantity. So delta P upon delta T. So either in terms of reactants or in terms of products. As the time passes, the amount of the reactant is decreasing. And the amount of the product is increasing. If you plot a graph with the time and the reactant amount, then in the beginning, at t is equal to 0, at t is equal to 0, amount of reactant is maximum. As time passes, it is decreasing and decreasing and decreasing, and it will go parallel. The reaction we say that continues very slowly, slowly, slowly. It will be moving. If it is not touching, actually, it will be moving like that only. Even in the last moment also, there is a bit of reacting slowly, slowly, slowly. So this goes, it continues, it continues, it continues, continues. A final thing that will take longer time. If it is in the case of products, the graph will be in the opposite direction, that is time, and this is product. So initially at time t is equal to 0, p is equal to 0, no product. As the time passes, it increases and finally it goes parallel, like that. That continues. That means the product formation is continuing and continuing and continuing. Same infinitely it goes like that. So these are the costs for reactant conservation and product conservation. All right. So for a reaction, we are talking the speed in terms of reactants. We are talking the speed of the reaction in terms of the products also. Now look at this decomposition reaction. HI gives H2 gas plus I2 gas. You see, HI is getting decomposed to form H2 and I2. At a time, two molecules of HI are going disappearing. Disappearance means 2HI, 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 like that. The disappearance is like twice instead of HI. Formation, if you talk in terms of hydrogen, one molecule of H2, one molecule of H2, one molecule of H2. If you talk in terms of that product, I2, that means one molecule of I2, one molecule of I2. So here, I told you in terms terms of any reactant or any products, you can talk speed of the reaction. But HI, the way HI is going, double going, the way H2 is appearing, 1 only 1 appearing, and I2, in terms of I2, only 1 is appearing. But for the rate of a reaction, the rate should be the same throughout. The rate should be the same throughout. It's not like that double is going and only single things are coming. So what we are going to do in terms of every reactant to make the reaction rate same throughout, what we are going to do is divide the rate of the reaction in terms of HI by its stoichiometric coefficient. You cannot see. So what we are going to do is minus delta HI upon 2 delta T. 2 is coming in the denominator to make the rate same. To make the rate same in terms of each and every reactant and product. Equal to plus delta H2 upon delta T is equal to plus delta I2 upon delta T. So whatever will be the stoichiometric constant that we'll be writing in the denominator to make the reaction a constant. This much is called the rate of disappearance of HI. The whole thing is rate of the reaction. This, without the stoichiometric constant, what all things are there? That is the rate of disappearance or rate of appearance of products. So by the removing the stoichiometric coefficient, that is 2, or any stoichiometric coefficient, whatever it is, do not consider that, except that everything is gone. The rate of disappearance of one reactant or the rate of disappearance of a product. Write down one equation. N2O5 gives NO2 and O2. NO5 N2O5 gives now in this equation 2N is 4N. 10O 8 plus 2 10. Balanced equation. What is the rate of reaction in terms of this? What is the rate of reaction in terms of this? What is the rate of reaction in terms of this? Rate of reaction, call it as average rate or rate average. It's called average rate or rate average, RA. That is minus 1 by 2 delta N2O5 concentration upon delta T. Coming in the denominator. Here plus 1 by 4 NO2 upon delta T equal to plus delta O2 upon delta. So this is rate in terms of this is rate in terms of this one, this is rate in terms of that. In each and every case, the corresponding stoichiometric coefficient is kept inside in the denominator. Now, what is the rate of disappearance of N2O5? That is this much. What is the rate of appearance of NO2? That is this much. What is the rate of appearance of oxygen? That is the same. So there is no number in the denominator. So if rate is given, you can find out the rate of disappearance of the reactant. you can find the rate of appearance of any one of the product. Rate of a reaction. What type of reactions we are able to learn its speed, its rate, the velocity of the reaction. Very speedy reactions within a blink of eye that will get over. For example, neutralization reaction. Neutralization reaction that is between sodium hydroxide and HCl, strong acid and strong base. Within fraction of second, the reaction gets over. You will not be able to start a stopwatch to move the time even. So such reactions, we cannot find the speed of the reaction. Some other reaction means it takes so many years to complete. Means change of diamond into carbon. It will take lakhs of years to complete. So such reactions they also we are unable to learn. We are able to learn only those reactions in our capacity that within 3 hours, a reaction which gets completed within 3 hours, maximum 2 hours, you have 1 day like that. So in the laboratory consideration, we'll be thinking about that 3 hours, 2 hours. In that course, 3 hours, what types of reactions can be completed? By starting a stopwatch, how can whether you can measure the change in half an hour interval, only such type of reactions are under consideration. So rate of reaction is the change in concentration of reactants or products in time. Right, one question. In a reaction, two agrees products. In a reaction, the concentration of A decreases from 0.5 volts per liter, 0.4 volts per liter. Within a time, 10 minutes. Calculate the rate during this interval. Calculate the rate during this interval. So this is in terms of A. So in the taking minus of rate average. The rate average is equal to minus 0.4 minus 0.5 upon what is delta T minutes. And that too is to be taken in the denominator. That is 2 in the stoichiometric constant. So you will be getting this much molar x volts per liter. Volts per liter per minute. So you can write this in terms of molar. Volts per liter means molar per minute. Minute. So that's about the rate of reaction. Now, rate of reaction depends upon the concentration of the reactants. In the beginning, the rate of reaction is very fast because a lot of reactant molecules are there. Reactant molecules collide each other to make the product. Since the number of reactant molecules are more in the beginning, the rate of reaction is higher in the beginning. As time passes, the amount of reactants are getting lesser and lesser. So, what happens? The speed of the reaction also getting decreased. So what is the rate of the reaction? In the beginning it is very high. In the end it is very low. So what is actually the rate of reaction? Rate of the reaction we have to consider in this much interval, in this much interval, in this much interval. In the beginning in this much interval, this is the rate of the reaction. After some time rate decreased, this is the rate of the reaction. After some time again the rate is decreased, this is the rate. That is again lower. Then what is the rate of the reaction then? So rate of the reaction, it keeps on decreasing, it keeps on decreasing. It's not like that we are driving a car. In the beginning the speed is high, afterwards the speed is low, afterwards the speed is again low. It's not like that. See, when we drive a car, that depends upon the conditions of the road. Maybe in the beginning, very slow speed. After some time, we can raise, we can accelerate. After some time, according to the condition of the road, the speed of the car may be increasing and decreasing. But in the case of reaction, the speed is decreasing and decreasing and decreasing from the beginning. Beginning high, because how this reaction takes place, like the collision of reacting molecules. In the beginning, so many reacting molecules are there. Rate is proportional to the concentration of the reactants. So many reacting molecules, all are colliding each other and the products are formed. So in the beginning, the rate is very high. As time passes, see, reacting molecules are getting converted into products, the number of reacting molecules are decreasing. So the rate is also decreasing. So in the case of a reaction, the rate is decreasing and decreasing and decreasing. Actually, what is the rate of the reaction? Average rate, you can tell that during this interval, this is the rate. So we call it as average rate. Since the rate is changing and changing and changing, what is the point of telling the speed of reaction? So we can talk in another term that is instantaneous rate. Instantaneous rate means at a particular time, what is the rate? At a particular time, what is the rate that is called was instantaneous rate? Instantaneous rate is measured how you reduce this delta t. Limit delta t tends to 0. Limit delta t tends to 0. That is the instantaneous rate. Means at this point. Between 200 seconds to 400 seconds. Between 200 seconds to 400 seconds. In the gap, we say average rate. But at 300 seconds, we say instantaneous rate. So during a time interval, it is average rate, and at a point, that is instantaneous rate. Okay, thank you.